Hello my dear learner, welcome to another mathematics lesson. This time we are going to start a new topic. The topic is area approximation. Area approximation. You know how to find area of regular shapes like a rectangle. The area has its formula, length times width. If it's a triangle, it has its formula, half times base times the perpendicular height, and other regular shapes. In this topic, we are going to learn how to approximate area of irregular shapes. Area of irregular shapes. I'm sure you've learned how to find area of irregular shapes in mathematics form 1. You may have learned the same also in physics. You may have learned the same also in geography. Because in geography also we have maps, and maps usually have irregular shapes. Just to remind you some of the ways we normally use to find area of irregular shapes. Let's say this is an irregular shape. This shape is irregular. So you can trace out this shape and place it in a grid of 1 centimeter square. Like that. Mine is just a sketch, but you trace out the figure and place it in like a graph page or a graph book which has those squares. Each big square of that graph book is 1 centimeter by 1 centimeter. So you can now estimate by counting the full squares, because each full square is 1 centimeter squared, and then the partial squares like this one, you count them as a half. You estimate. Remember, we are approximating, we are just estimating. So we assume all the partial squares are, each one of them is a half centimeter squared. So you count the full square, the full squares. If, for example, there are 24 full squares, it's just an example, and we have, let's say, 20 partial squares, so you just multiply the partial squares times a half, because each one of them is half a square centimeters. So you just add 24 centimeters squared plus the half of 20, which is 10, you get 34. That is one way of finding area of irregular shapes. The other way of finding area of irregular shape is by tracing out or by drawing, taking irregular shapes. Like we can draw a triangle here which has a base and a height. We are just estimating maybe a rectangle, another triangle here, something like that. And then you find the area of those three shapes. For those shapes you already know the area, so you can estimate the area of that irregular shape that way. So but for today I'm not going to dwell so much on that. I will go to a method called the trapezium rule or the trapezium method. So that is what we are going to learn today, approximating area by the trapezium method. Approximating area by the trapezium method. The trapezium method is also called the trapezium rule. If you look at this chart here, my dear learner, we have an irregular shape here which has been shaded. It is on a Cartesian plane with x-axis and y-axis. So if you look at this shape, this is a graph. It has an irregular shape. The scale for the x-axis here is one square representing 2 units. For the y-axis, 1 square representing 1 unit. So we can divide this shape. We want the area of this shaded part. We can divide this shape into trapezium. The plural for trapezium is trapezia. So we can divide that shape into different trapezia. Like here we can divide into, I have already divided it into 4 trapezia. Trapezium A, trapezium B, trapezium C, and D. So this is not exactly a trapezium because this is a curve, but we are assuming, we just assume it is a curve, because if I draw a straight line here from this point to this point, it actually forms a trapezium. The same for B. If I draw a straight line from here to here, it forms a trapezium. So what we are going to do here, we are finding area of each trapezium because we know the formula for finding area of a trapezium. So we find area of each trapezium, then we add the areas, the 4 areas. Let's do that, my dear Lana. Let's do that together. The first one here, first of all, what is the area for trapezium? A trapezium, the formula for area of a trapezium is a half A plus B times H, where A and B are the parallel sides. H is the perpendicular distance between the parallel sides. For example, if this is our trapezium, the parallel sides is this and this, and then this distance, this perpendicular distance between the parallel sides is H. So using this formula, let us find area of trapezium A. Area of trapezium a half, the formula is a half, into brackets, A and B are the parallel sides. This is a parallel side, so this one is 4 units, plus B is this distance. This distance is approximately 3.5. So we can say 3.5. Remember, I don't have small squares here, but in a graph, you count the small squares to be more accurate. So, and then multiply that by H. H is this distance from this parallel line to this other parallel line. That is 2 units. For x-axis, each square is 2 units, so times 2. If you do that correctly, my dear Lana, you get, these 2 will cancel with this. You will get 4 plus 3.5, that is 7.5. 7.5 square units. 7.5 square units. That is the area of the first trapezium, trapezium A. Area of trapezium B. The same formula again, a half in brackets A plus B. For trapezium B, this is A, this other length is B. This length is 3.5 plus this other length is 3.0. Then multiply by the distance between this parallel side and that other parallel side is again 2 units. If you do that correctly, my dear Lana, you get 6.5 square units. Then area of trapezium C. Area of trapezium C, we use the same formula again, a half in brackets, A plus B. For trapezium C, length A is this one here, which is 3 units, or 3.0, plus length B is this one, which is approximately 2.2 units. Then multiply that by 2, the height remains 2 again for C. That gives us 5.2 square units. Then the last one, area of trapezium D. We apply the same formula, a half times for trapezium D. This length is 2.2 plus this length is 2.0. 2.0 multiplied by the height there, or that distance, the perpendicular distance there, 2 gives you, if you do that correctly, 2 and 2 will cancel, you have 2.2 plus 2.0, which is 4.2 square units. 4.2 square units. Then now, to get the total area of that shape, you add the 4 areas. So the total area, my dear learner, will be 7.5 plus 6.5 plus 5.2 plus 4.2. What does that one give you? 7.5 plus 6.5 is 14. 14 plus 5.2 is 19.2. 19.2 plus 4.2 gives you 23.4. So the total area of that shape will be 23.4 square units. 23.4 square units. So we have found the area of each trapezium, then we added the area of the trapezium. We added the area of the trapezium. Now, I want us to look at something. I want us to come up with a formula, because that is a long way of doing it. There is a shorter way of doing it. Let us assume this length, the first length there, or the first parallel side of the first trapezium is y0 or y0, y subscript 0, this length. This one here is y1. Our y0, remember, is 4. Our y1 is, we say, is 3.5. Then this other, the third one is y2. The fourth one here is y3. And the last one there is y4. So if we find the area of each trapezium and add, then the total area is area of trapezium A, which is a half. We are now using the letters y, these lengths, y0, y1, y2, y3, up to y4. Area, a half for trapezium A, a half, this is a half, in brackets, the first parallel side is y0 plus y1 times h. We are assuming the length from here to here is h, and it is the same for all of them. So add area of trapezium B, a half, y0, not y0 now, it will be y1 and y2, y1 plus y2 times h, plus the third trapezium, a half. For the third one, trapezium C, the two lengths will be y2 and y3. So y2 plus y3 times h. Then the last one, D, will be a half, brackets. For D, it will be y3 plus y4. y3 plus y4 multiplied by h. I want us to observe keenly what we are going to do here. So if you look at this sum, a half is common. H is also common. So what we are going to do is we factor out a half h. Listen carefully, we are factoring a half h, because in every term, this is a term, this is another term, the third term, the fourth term. In every term, we have a half h, a half and h. So factor out a half h, you will remain with y0 plus y1 here. Here you remain with plus y1 plus y2. And here we have y2 plus y3. And then the last one here, y3 plus y4. Close the bracket. Observe keenly. We can make this simpler. Because if you observe keenly, you will notice that, my dear learner, the first y0, and the last one are not repeated. But all the others have been repeated. That tells us something. All the others have been repeated. Apart from the first y0, and the last one, y4, all the others have been repeated. y1 has been repeated. There are two of them, y2 repeated and y3 repeated. So we can simplify this therefore and write it as a half h, open an outer bracket. We are going to use two different brackets now. That's why I'm using a different shape. Open an outer bracket, then an inner bracket. First one, the first inner bracket is for these two, y0 and y4, because they are not repeated. y0 plus y4, not repeated. Then for the others who are repeated, you double them. You say 2 times y1 plus y2 plus y3. Close the bracket, then close the outer bracket. So this one now has made this to be simpler. We have at least compressed. So actually this is a formula for finding area of a trapezium, area of an irregular shape using the trapezium method for a shape where the area has been divided into 4 trapezia or 4 ordinates. We can also call these ordinates. Ordinates. If the area has been divided, or that region has been divided into 4 ordinates, then you will have y0 up to y4. If you had divided this shape into maybe 6 ordinates or 8 ordinates, then you will have y0 up to y8 for 8 ordinates. So the formula will be a bit different because it will be now here y0 plus y8 if there are 8 ordinates, and then the remaining, all the rest, that is y1, y2, y3 up to y7 will be repeated. So we just come and change here and here. So if you look at the chart now, the first area here is for this specific graph which has been divided into 4 ordinates. 4 ordinates or 4 trapezia. So if the shape has been divided into 4 trapezia, the area will be a half times h. A half h. Remember, in this case, h is 2. That's why I have written here a half times 2. Because I already know that h is 2. So a half times 2. Open outer bracket. Then inside the bracket, add the first and the last y's, that is y0 plus y4, then plus 2 times of the remaining ordinates. So these are the ordinates, y0, y1, y2, y3, and y4. So, but generally now, the second formula here, which I have written here, is now the general formula for finding area by trapezium method, where we have n ordinates. N can be 3, 4, n can be 10. So it will be now a half h, open the outer bracket, and then inside the brackets we have the first bracket y0 plus yn. Remember, if we have n ordinates, it will move from y0 up to yn. For 7 ordinates, from y0 to y7. For 10 ordinates, from y0 to y10. Then plus 2 times the remaining ordinates. Remaining is starting from y1, y2, y3, plus y4, plus y, until you get yn minus 1. That is, if here n is 10, y10, then this one should be y9. I want you to take that keenly. If here n is 8 for 8 ordinates or for 8 trapezia, if here we have y8, then it will go up to y? Up to y7. So this is the general formula for finding area of irregular shapes by using the trapezium method. The trapezium method is also called the trapezium rule. So this is actually what we call the trapezium rule. Sometimes it is also called the trapezoidal rule. You may find in some books it is called the trapezoidal rule. So it is all the same thing, the trapezium method, the trapezium rule, or the trapezoidal rule. So I will stop there, my dear learner. In my next lesson, we shall look at examples on this. We shall look at examples of questions on this, and then we solve the questions using the trapezium rule. So thank you for watching. Bye bye.